All right, we're on lesson 5 and we're on example 2. We're finding the volume of a solid, and we've got the base is a circle, x squared plus y squared equals 9, so we've got a radius of 3. The cross-sectionals are perpendicular to the x-axis, and they happen to be isosceles right triangles, and the hypotenuse is laying on the base of the circle. So this is the hypotenuse of the triangle. So if we look at the hypotenuse here, that's a bad drawing. I'm going to start over with my drawing. So if we look at the hypotenuse, if it's isosceles right triangle, that means this is 90 degrees. My hypotenuse is this distance here plus this distance here. So I have y and then another y. So I have y and another y. For my height, since this is isosceles and it's a right triangle, that means this is a 45-degree angle, which means this side is also y. So if I want to know the area of my triangle, we have 1/2 the base, which is 2y, times the height, which is y. So when I multiply that together, the 2 and the 1/2 cancel, and the y's become y times y is y squared. So the area of my isosceles right triangle is y squared. But we have a problem. We can't integrate with respect to y because it says they're perpendicular to the x-axis, which means I really need to integrate with respect to x. So I need to solve my equation, and so it's in terms of x. So right now we have x squared plus y squared equals 9. If I subtract over the x squared, I get y squared equals 9 minus x squared. And lo and behold, we said the area was y squared, so I get to use this 9 minus x squared. I don't have to take the square root of y because I said the area was already y squared. So when we go to find the volume, we are going to have to use symmetry here, and we're going to have to go the integral from 0 to 3. From 0 to 3 would be this half, and whatever happens on this half, the exact same thing is happening over here. So that's 2 of those things are happening from 0 to 3. And we said that the area is equal to y squared, but then we know that y is equal to 9 minus x squared because we need this to be in terms of x because it's perpendicular to the x-axis. We want to have the integral with respect to x. All right, go ahead and pause it and integrate it, and we'll see if we come back to the same thing. All right, so you should have got 9x minus 1/3 x cubed from 0 to 3, and that's times 2. So then when we plug that in and integrate it, we're going to get 27 minus 9, which tells us that the volume is going to be 36 units cubed. A lot to take in all at once. Don't be afraid to pause and go find other videos that will be helpful for you, or go back and replay it, work through each step again, see if that doesn't help clarify some things. Number 3, we are dealing with this sort of sideways parabola. It says x equals y squared, x is 9. So this line is one boundary, and this curve here is the other boundary. So this is the base. And it says that our solids are a semicircle. So this is making semicircles all the way down through here. Semicircles. Okay? All right, I hope that helps you to visualize. And they're perpendicular to the x-axis. So again, we're going to have to be doing this with respect to x. So if we look at our semicircle, again, the height here is y, and then going all the way down here, that's y again. So remember, area of a semicircle is 1/2 pi r squared. In this particular instance, we have the radius being y. We know that x equals y squared. So if we put this in terms of y put the in terms of x instead of y, so we get the y all by itself. Y equals the square root of x. All right, so this right here is the square root of x, which you can definitely tell that's the square root function right there, right? This is the positive one, that's the negative one. So for our area, we have 1/2 pi, and then our radius here is y, but since we need it in terms of x, it's actually the square root of x squared. So our area formula is going to work out to pi over 2 times x. That doesn't seem too bad. Now, when we go to integrate it, where are our bounds going to be? Well, looks like we are bounded from here over to here. So it looks like we're going from 0 to 9. Remember, we're doing this with respect to x, so that's why I'm looking at the x values for my boundaries. And we're integrating this area function down here, pi over 2 times x. So go ahead and pause it, and you can integrate it and see if you come up with the same answer that I do. All right, so it looks like we're going to get our volume equals 81 pi over 4. And remember, these are units cubed. All right, going on to example 4. The volume of the solid whose base is the region bounded by the lines x plus 2y equals 6 and x equals 0, y equals 0. So these are telling us that our boundaries are the x and y axis. And we just need to graph this little line here. When we're doing this, we're just doing a sketch so we can tell, what's going on in our picture. So this line right here, if it helps you to put it into y equals form, the mx plus b form, maybe that will make that a little easier for us. So we'll have 2y equals negative x plus 6, divide everything by 2, get negative 1/2 x plus 3. So my y-intercept's here at 0, 3. And then my x-intercept is going to be happening when this is 0, so x is 6. So 6, 0. All right, so I have a line going like this. And it's also bounded by the y-axis and the x-axis, which means I'm talking about this region right in here. So now we just have to decide if it's easier to do it with respect to x or y. Oh, nope, we're not deciding that. It tells us, doesn't it? They're perpendicular to the y-axis, so we need to do this with respect to y. Pay attention to our directions, right? Okay, so we've got to do the rectangles that go horizontal. All right, and our cross sections are equilateral triangles. So I have little equilateral triangles that are coming up all the way down here. All right, cool. All right, so we want to find the area of one of those little equilateral triangles. So let's see. They're equilateral, which tells me that they're going to be 30, 60, 90 triangles when I cut one of them in half. This distance right here, just like when we had the distance in the previous problem going up and down, was y. This distance is going to be x. All right. And if it's equilateral, that means all these sides are x. So that means the long leg here, this would be 1/2 x for the little short leg. The long leg here in a 30, 60, 90 triangle is going to be square root of 3 over 2 x. Right, if you've forgotten your 30, 60, 90 triangle information, you could pause the video and go watch another video about special right triangles real quick. Awesome, so our area is going to be the base times the height. So 1/2 x, 1/2 the base, which is x, times the height, which is square root of 3 over 2 times x. All right, so this is our area for all of our little cross sections going here. All right, so we've got base times the height. So now we just have to figure out what x is here exactly. And I think if we go up here, we can see pretty easily if I want to solve this for x, we're going to see that x equals negative 2y plus 6, or 6 minus 2y, whichever way you want to write it. All right, so when we go to integrate this, the volume is going to be the integral. And remember, this time we are dealing with bounds with the y values because we're doing this with respect to y. So our y bounds are going from 0 up to 3. All right, and we have the 1/2 times x, which we said was negative 2y plus 6, times the 3 square root of 3 over 2 times x, which is the same thing again. And I know it looks messy. We'll clean it up. dy. Okay, so this is all this other stuff we were doing. Okay, so it looks messy, but if we look at it, we've got some constant terms here we can pull out front, clean it up a little bit. So we're going to have square root of 3 over 2 times 1/2 fractions, multiply the bases. We get square root of 3 over 4. And we can pull that right out front and not worry about it. I notice in here I am multiplying the same thing times itself. So we're really doing negative 2y plus 6 squared dy. All right, it's up to you whether you want to do it like this with u substitution, or you can multiply it out and get the polynomial. That's what I'm going to do. So let's do that first. We want to do that before we integrate. So you just do a generic rectangle, right? Negative 2y plus 6 times negative 2y plus 6. And work that out. We should get 4y squared minus 24y plus 36 dy. All right, integrate it and come back here and we'll see if we get the same answer. And again, it's units cubed, so we have 9 times the square root of 3 units cubed for that one.